Good day everyone, and welcome you back to Global Education Zone. Today, in this episode, which is the first episode of our crash physics for senior secondary school, this episode will be dealing with units and measurements. So, from what you can see at first, there are three fundamental um, measurements units, and this unit of measurements, they are the length, the mass, and the time. Now these they are also known as quantities, and they have their units, which are the mediums by which you measure them. Now these fundamental quantities, your length is measured in meters naturally, then your mass is measured in kg according to the international system of measurement, then your time is measured in seconds. So here we have definitions of the fundamental quantities, which are basically they include the length, mass, and time. And these definitions, we say the fundamental quantities are the quantities that are independent of other quantities and cannot be derived or defined in terms of those other quantities. They are just like the grassroots quantities, they are the basic ones. Then those fundamental quantities, they are measured using fundamental units. For example, your length is majorly measured in and can also measured in centimeters. Now that centimeter is a unit, while the quantity itself is length. Next, let's talk about the derived quantities, which are not the original quantities, but they are gotten by a simple combination of the fundamental quantities. Now, the table here talks about the six major fundamental quantities in the first column, their units in the second column, and then their abbreviations in the third columns. So you can say we have the length, which has a unit of meters, your mass, which has a unit of kilograms, time, which has a unit of seconds. Then we also have the rest like electrical quantity of substance, which is in mole. We also have and so on and so forth. Next, we have the derived quantities, their derivations, and their derived units. So you can see that area is gotten as length times breadth. And since the unit of both length and breadth is in meters, so that means when you multiply meters, their derived unit is meter squared. For volume is in meter cubed. For density is kilogram per meter cube. Then we also have velocity is displacement with time, acceleration change in velocity with time. So each of these they have their corresponding derivations, and those derivations they match with their fundamental quantities combined. Next, we are talking about the instruments used to measure fundamental quantities like mass. So now these instruments they are very important because without them we wouldn't know what these quantities represent in magnitude and in direction. So now we have this is a ruler, and you can see the correct way of drawing a rule of looking at a ruler. When you are making use of the meter rule, that's the correct direction. You look at it from straight downwards. If you look at it from the slant, it will give you what is known as parallax error. If you look at it from either side, from the left side slanted or from the right side slanted, you get a parallax error as a result. So basically what this means is that parallax error is basically the when things change as you change your perspective. When you move from one place to another, your perspective of something changes. That's kind of the reason for parallax error. Now there are other instruments used to measure length like the calipers. And the calipers, you can see it is used to measure the outer diameter of a cylinder. That is called an outside caliper. We also have the inside caliper, which is used to measure the inside diameter of cylinders and cylindrical objects. And then after you have measured it, you can see that you can transfer the length to a linear scale like your meter rule. We also have another instrument for measuring length, and this is vernier caliper. So you can see the inside diameter. Those are the two cylinders. That cylinder is being measured. It's measuring its internal diameter. Then on the lower side, we can see the two prongs used to measure the external diameter. And the vernier caliper has one unique property. It has a vernier scale that slides along its main scale. Now the main scale measures in millimeters, while the vernier scale measures 9/10 of a millimeter. So that is how the vernier scale works. They also have the locking screw to lock it in position. So the main scale is actually long, but it has been sectioned out, it has been cut out. So you can see the cutting lines. We also have another wonderful instrument called the micrometer screw gauge, and this instrument is even more accurate than the vernier caliper. It's used to measure the thickness of cylindrical objects that are very small in size. And then, as you can see in the diagram, what you need to do is you place the object in between the axle and spindle of the micrometer screw gauge. Then you have your frame, the main scale, and then in this case it has a circular vernier scale, and the vernier scale it measures to one more decimal place than the vernier caliper. So the micrometer screw gauge is accurate to 3 decimal places of the centimeter. And then you can see the various parts, and these are this is how it looks. It's very close to its real shape. You will recall that we talked about another fundamental quantity, which is mass. And mass can be measured with different instruments, which include the chemical balance, which you can see here, and it has a left and a right scale, and then at the middle between those scales we have pointers. So how this operates is you make use of standard masses. When you put an unknown mass in one side of the scale, then you keep balancing with small amount of standard masses. Then when you get to a point where the scale is at the 0 point or at the midpoint, that means the mass of that unknown object is equal to the mass of those standard masses. So when you add them together, you get the total mass of the unknown objects. Now I want to point your attention to something in physics, because most of the time there's often a misconception between mass and weight. So mass is a fundamental quantity, but weight is a derived quantity, and weight is very different from mass, because as you can see, the instrument used for measuring weight is majorly called the spring balance. So though there are other instruments used for measuring weight, so but majorly we make use of the direct reading balance, so and it measures the weight directly. So the weight is different from the mass, because the weight is actually a force that is equal to the force that is acting upon a body of a particular mass, that is proportional to the magnitude of that mass, and there's a constant, which is the gravitational constant, and or rather the acceleration due to gravity. When you multiply that mass and the acceleration, you get the force exerted on a body on the earth, and that is the weight of the body. Now moving on to volume, which is a derived quantity. It also has the instrument used to measure it, like your pipette, your volumetric flasks, measuring cylinder, and burette. Now these are typical chemistry laboratory instruments, but you can also see them in your physics lab, because whenever you're making use of whenever you're trying to perform experiments involving density and all the rest, and involving volume in physics, you can also use this apparatus. So these are majorly used to measure volume, and these are volume volume devices, measuring devices. There's another um, fundamental unit which we shouldn't forget about, and that is time. As those of you who would have read wide in physics will know that time is the fourth dimension in our universe, and time also has a lot of instruments used to measure it, like a watch. The example is that stopwatch, and most stopwatches they measure times to the hundredth to the hundredth order. So that is to the second decimal place. That is to the nearest 0.01. So, and also have your stop clock depending on the accuracy. Now there's a last concept which you need to understand, which is the dimensions of a quantity. Now, for example, let me give an example. When we're looking for the dimensions of pressure, that is equals to force over area. So it is the dimension of force divided by the dimensions of area. So the dimension of pressure will be equal to the dimension of force, which is mlt raised by minus 2 divided by l raised by 2. That's ml raised by minus 1 t raised by minus 2, and so on and so forth, where m stands for the mass, l stands for the length, and then t stands for time. So dimensions are used to verify the existence of an equation. So this is as far as we can go. Thank you for watching. See you next episode.